we are going to study Boolean algebra, logic gates, and algebraic simplification. So what does this simplification means? So we are going to do simplification of Boolean expression, which is using Boolean algebra. So in the last class we have used dual of Boolean expression. To find the dual of Boolean expression, we can interchange or do AND expression. Literals are left unchanged, and Boolean algebra laws are left unchanged. So if you notice one thing, then Boolean algebra, so these Boolean algebra and number theory and this are analogous to each other, right? For example, in Boolean algebra, this we have 1, 0, right? And in number theory, over here 0, 0, 0, 1, 0 is 0, 1, 1 is 1, 0, 1 is 1, 0, and here 0 into 0 is 0, 0 into 1 is 0, 1 into 1 is 1. So this is how this is all done. So this is your AND, but this is not your AND, this is your multiplication. In Boolean algebra we don't have multiplication, but this is an analogy which we have created, right? Similarly, 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is 0, 1 plus 1 is equal to 1. This won't be 1, this is not addition, this is OR operation, right? Because this is Boolean algebra. But the same thing when we do in number theory, it becomes 0 plus 0 is 0, 0 plus 1 is 1, which is 1 plus 0, and then here 1 plus 1, which is equal to 2. So this is addition, right? For example, tell me one thing, what is 0 into x? It will be 0. And what is 1 or x? It is 1. So this is the idea, right? What will be 0 or x? That will be x, right? What will be 1 to x? It will be x. Now okay, now let's solve this one. Number of Boolean function over 4 variables. How many Boolean functions we have such that f equals to f complement? So the answer will be 0, because f is never equivalent to its complement, never, right? Now simplification of Boolean algebra. So for simplification we have many techniques. हमारे पास बहुत सारी टेक्निक्स हैं, लेकिन आज हम लोग पढ़ेंगे algebraic simplifications, राइट? इसका मतलब होता है कि हम Boolean algebra के यूज से सिंप्लीफिकेशन करेंगे. सिंप्लीफिकेशन यूजिंग Boolean algebra. ठीक है? Let's see a question. A B bar D plus A B bar D bar. Let's simplify this thing. What we'll get? Now here A is common. You can see A is common. B bar is common. But first try to understand this thing in Boolean algebra. If there is AB plus AC, we can write AB plus C. Which property is this? Distributive property. इसे कहते हैं डिस्ट्रीब्यूटिव प्रॉपर्टी. इसमें हम a को बाहर लाके कॉमन ले सकते हैं. सो a को कॉमन लेते हैं इन दोनों में से और b प्लस सी हमको मिल जाता है. जैसे कि अगर हमारे पास a प्लस ए सी है तो हम फिर से a को बाहर ला सकते हैं और 1 प्लस सी हमें मिल सकता है. राइट. So finally it will be A into 1, that is equals to A. Now let's continue on our question. So A B bar is common, right? So again this is D plus D bar. Now what this thing is, this will be 1 because one of them will be 1. If D is 0 then it will be 1. If it is 1 then it will be 0. So this will be 1 only. So you'll get AB bar finally. So this is your final answer. Right? This is your simplified expression. Let's solve the next question. A plus B, A plus C. Now second point, for example you have A B plus C, right? So you can multiply over here. आप यहाँ पे मल्टीप्लाई कर सकते हैं. मल्टीप्लाई करने के बाद आपको मिलेगा ए बी प्लस ए सी विच इज ए प्लस बी सी प्लस डी ओवर हियर. राइट. अगर ये है तो फिर से ए इंटू सी plus again A into D, again B into C plus B into D. Right, so this is how you do. Okay, so this is the thing. Now we can multiply over here. A into A is equal to A, right? So this will give you A which is A plus then you'll get AC. After that you'll get BA and then BC, right? This is your multiplication. This will become A. So one rule we have seen in the last class, which is the absorption law. So for which if you have A plus A alpha, so you can take A common, 1 plus alpha. So it will be A. Right? So this A will, okay, over here, this will be absorbed by A. So this will be same as A plus BC. It will be A plus B, A plus C. So this is the given expression by distributive property. Okay, so now let's move to the next question. Over here A bar plus B, here it is A plus B. Now when you multiply, it is A bar into A, which is actually 0. Then A bar B plus BA plus BB. which is equal to B. So 0 plus anything is alpha. Alright? So we get B plus AB. Here it will be A bar B. Now again, absorption purpose only. This will be absorbed. Why? Because B plus B into anything is B. Alright? This will be equal to B. Final answer will be B. So let's solve this one. Before that, remember this absorption law. So then what will happen over here is that this alpha will absorb this. So these two will become alpha, right? Then this will be absorbed, then this will be absorbed. So the final answer will be alpha only. For example, if you have A B bar C plus A B bar C D plus A C D E B bar, then remember this is your alpha into beta, and here also you have a alpha into some gamma. So this final answer will be A bar C only, right? Very simple. Now let's solve this question. Here you can apply the absorption law. So straight away apply the absorption law. This is the AC bar plus AC bar B. This is clearly your absorption law. This is your alpha. This is your alpha plus beta. So it will be alpha, which is AC bar. Or what you can do is that either you can apply the absorption law or you can take common. So it will become AC bar like this. After this, let's solve another question. A plus A bar, this will always be 1. If A is 0, then A bar will be 1, and vice versa. Next, what this will become? This you can multiply inside. A bar, which will be 0, plus AB, which will be AB. Next, A bar plus B bar, then A bar plus B, which is A bar plus A bar B plus A bar B bar plus 0, right? And then this is D, right? What you have to do is to apply the absorption law with these. Alright, here also again absorption law with this, and again another question which is like this: A B C D, which is A bar and A bar plus B bar plus C bar plus D bar. So this will again be absorbed. It will become A bar. Done. Right? How? If you want to understand, A bar plus A bar B bar plus A bar C bar plus A bar D bar, which is actually A bar 1 plus anything, which is actually 1 only. So it will be A bar only. Right? So one thing that we have noticed is that your absorption law is very important. Right? It will be used a lot of places. Alpha with anything, These things will be absorbed everywhere, and the final answer will be alpha only. Right? Now let's solve some more questions. A plus B plus B bar. Here let's use our associative property. B plus B bar. Right? See, we have used the associative property. Look at this. This will 1. Anything plus 1 is 1. Next question. A plus BC plus BC bar. Here what we'll do? It will become A plus B. We'll take B common. Right? This is A itself. This will become B. Now here which property you can apply? This is actually solved. A plus B is the answer. Now next question. A bar plus C plus AB. Over here, which property which you can be used? This A is redundant over here. This will be A bar plus B plus C. This is redundant. This property, we have seen this property in the last class, that if you have A plus A bar B, then this A bar is redundant. This will be A plus B. Okay. Next, what will be the answer for this? A bar B plus AC. So this will be A bar B plus A bar AC. This will become 0. This will be A bar B. Alright. Now let's solve another question. A bar plus B plus A B bar. Right. So over here it will be multiplied A bar plus AB plus AB bar. This will become 0, right? This will be AB plus AB bar. This is again AB plus B bar, and then again this will be 1 and this is A. Right? Now another question. A plus A bar AB plus AB C bar. Alright. So this will be AB only. How this will be AB? This is 1 already. Here you can apply the absorption law. Right? So this is actually C bar will be this will be absorbed and it will be AB. Now another question. A bar B bar C plus A plus B plus C bar whole bar plus A bar B bar C bar D. So this is your question. Now A bar B bar C plus A bar B bar C. So you'll apply the De Morgan law over here and then you'll get this. So this and this are basically same. Same, you can write them as 1. Because same thing can be written as 1 time only. Now you'll take it as common. A bar B bar is common over here. And then what you'll get? You'll get C plus C bar D. And again the one thing is redundant over here. This is redundant. So this will be A bar B bar and D. B bar D. The final answer will be A bar, final answer will be A bar, B bar, C plus D. Let's solve. So A plus B. This is your absorption law. It will be A. B. A bar plus AB. This will be AB. How? This is your why? Because A will is 0 and AB is AB. C. So in option C you can take C common. Right? So it will be C. Here this will be redundant. Right? Same as option A, it will be A. And in option E, A, B bar, C, A bar. Here and here there is something common. A bar, C you can see common. A, B bar, C plus A bar, C common. Now you can take C common. So A bar plus A, B bar. Now this will be redundant. C A bar plus C B bar. So these things are very important. Alpha plus alpha bar beta and alpha plus beta. Why? Because this is redundant. Here this is alpha plus alpha beta. This will be alpha. This is your absorption law. Here this is redundancy or redundant. Now, okay, so now what is the answer for option A over here? A, B bar. Here you can apply the absorption law. These two. Look at these two. You can apply absorption law. A, B bar plus A, B, C bar plus A, B, so here it will be B bar plus BC bar. A, B bar plus C bar. Here it will be BC. Here it will be C. Here it was absorption law. In C we'll apply De Morgan's law. Or we can say BC common. Alright. So you get BC D plus D whole bar plus BC D. Right? Now since you know that alpha plus alpha bar equals to 1 and alpha bar equals to 0, so if you take this BC common, this will be 1, so we'll get this BC. Now BC plus BC bar D. So what this is? This is the redundant thing. Alpha plus alpha dash beta. This alpha dash is redundant. So this will be BC plus D. If this is your alpha, this is alpha dash. Let's solve the last one now. Where B bar C bar D plus applying the De Morgan law, B bar C bar D bar plus B bar C bar D bar E. So you can apply absorption. It will be B bar C bar plus B bar C bar D bar B bar C bar. Alright, you can take them common. Again you'll get D plus D bar, which is 1. So you'll get B bar C bar. Right? Okay, so moving on. So this is your X bar Y Z. So here you can notice that X bar Y you can take common, right? X bar Y you can take common plus XZ. So this will be Z plus Z dash and XZ. तो ये क्या हो जाएगा? X Y X dash Y plus XZ. This will be your answer, right? Now next topic. Now, do you understand simplification? Yes, we have seen a lot of questions and a lot of exercises. Now, why simplify a Boolean function? What is the reason? What is the need? क्या जरूरत पड़ी है? Idea is very simple. If you simplify, अगर आप simplify करते हैं तो आप you can create a small circuit, right? आप एक छोटा सर्किट बना सकते हैं. फॉर एग्जाम्पल, अगर आपको एग्जाम्पल दिया जाए AC प्लस AB बार प्लस CB, तो बताइए सर्किट क्या होगा? E. तो आप सर्किट बनाएंगे इस तरह से. मार्केट से आप कितने एंड गेट खरीदेंगे? 3 एंड गेट. 3 2 इनपुट एंड गेट. AC AB bar, these you'll purchase from the market. Now how many 2 input OR gate you'll purchase? You need to purchase, tell me. So total so it will happen like this. So you'll be getting a circuit like this. So how many 2 input AND gate? 3. How many 2 input OR gate? 2. So this is your expression. Very simple. Now what you can do, if you simplify, then what you'll get? This is a situation over here, that E equals to, over here happy times of B, C is there, sad times A is there, so we'll kill AC. We have learned this thing in previous lectures. So finally you'll get AB bar plus CB, right? So from the market you only need to purchase now like this: 2 input 2 AND gate and 2 input 1 OR gate. This is the idea behind the simplification. Right? Now we simplify so that we can create a smaller circuit. We have to simplify the circuit. So look at the definition of literal ones. It is the variable in its original or complementary form is called a literal. For example, x is a literal, x bar, z bar, right? X, Y, Z are variable, right? And what is the literal count? There is something literal count. It kind of tells how big your expression is, right? For example, this expression over here. Here little count is 4. This is a big expression. Here, over here, look at this. This is very big. Here the little count is 10. But over here, little count is 4. But the variable is 1. Literal count means a big expression. If you simplify this expression, you'll get 1. Over here, the expression, if you simplify, you'll get 1. And the literal count over here is 0 for this expression, E2. Okay? Right, so over here, if you notice, the literal count is 2. And the little count over here is 3 and over here is 2. The expressions are same. What we do is that simplify them, we minimize them. So the main idea behind simplification or minimization of an expression is reducing the literal count. Now over here you can see that this a bar b along with this a becomes b, and this b bar c bar along with this b bar c becomes b bar, and then this total becomes 1. So what is the literal count for this one first? 8. And number of variables 3. A, B, C. Literal count tells how big the expression is, right? Now how will you do this question? Let's see. So will you simplify? No. So you can do this question by case method. If you do by K-map, it will take a lot of time. See this expression. This is a long expression. Before you apply K-map, then you have to find all the minterms using two methods. Using case method or Boolean algebra simplification. Let us do it by case method. So two cases will be there. Either A will be 0, that is our case 1, and case 2, which is k equals to 1. Only two cases are possible. Now, if A equals to 0, then this will be 0, this will be 0, and this will be B. So, it will be like this. This whole will be B, and here it will be 0, then it will be B bar B into C. A0 B plus C bar whole bar B. So it will be B plus C bar C. So B plus B bar C. You will get B plus C. For RHS, when A equals to 0, RHS will be, this was your LHS, RHS will also be B plus C. See, A0 B plus C. And here LHS, RHS are same. That is why this is a very simple method. Now A equals to 1. So this will become, what will happen? This will become A equal to 1. This will become 1. This will become 1. So the whole thing will become C. LHS will be C plus, this will be 0 complement 1 plus anything, and it is anything, which is 1. When A is 1, then anything plus 1. So again you can see they are same. So like this you can do. This by case method is very, it will be your favorite. Now let me tell you one more thing. What is the beauty of by case method? The error chances are very less. When you have a big expression, and one more benefit is there, it will take less time. Another benefit, in GATE exam you will get a scribble pad, and it will take less space, so you can save space. Now, we've seen a lot of conjunction simplification, by case method, Boolean algebra. So now your Boolean algebra is over. Everything we have seen. Now the next point is there. Cancellation law do not hold in Boolean algebra. What it means is that, for example, if AB equals to AC, then B equals to C. So can we cancel? Like A cancel? The answer is no. Very simple point. 0.1 equals to 0.0. Right? So if we cancel like this, but you can see 1 is not equal to 0. Is this clear? So cancellation law do not hold in Boolean algebra. Similarly, if a plus b equals to a plus c and you do this cancellation, then b equals to c. No. 1 plus 0 equals to 1 plus 1. But 0 is not equal to 1. So you cannot cancel. Alright? Cancellation laws do not hold in Boolean algebra. Okay, so we have done a lot of questions on simplification. अब हम लोग आगे बढ़ते हैं. हमने वेरिएशंस देखे, केस मेथड देखे, बूलियन अलजेब्रा देखा, ठीक है. सो अब नाउ cancellation laws do not hold in Boolean algebra. Okay. So, example, if AB equals to AC, then B equals to C. Is this true? No. Why? Because 0.1 equals to 0.0. But if you cancel like this, but 1 is not equal to 0. Right? So this is clear. So you cannot cancel. इसी तरह अगर a plus b is equal to a plus c, then b equals to c? No. Why? For example, 1 plus 0 equals to 1 plus 1. But 0 is not equal to 1. Right? So you cannot cancel. So cancellation laws do not hold in Boolean algebra. Now another question. If A XOR B equals to A XOR C, then B equals to C? If A XOR B equals to A bar XOR C bar C. This is the question. So can we say that B equals to C? What could be the counter example? What A should we take? Remember, this is XOR. Is this statement true or not? This statement is true. Why? Whether you take A equals to 0, A equals to 1, then what this will become? If A is 0 or A equals to 1, if A is 0, then B. Here if A equals to 1, this will become C. Right? Here this is B bar, this is equals to C bar. Right? So B equals to C. So the first one is correct. Now the next case. So if A equals to 0, you'll get B bar equals to C. Right? When A equals to 1, you'll get B equals to C bar. So can I say B bar equals to C? So you can say in both the cases B equals to C bar. Right? Now can you say by case method is favorite? Nice. Right? This A equals to 0 equals to 1. In both the cases see what is happening and you'll get the result. So this type of tricky questions can come in your GATE exam. Now which of these are true? So if A plus B equals to A plus C and A equals to 0, A plus B equals to A plus C and A is 0, then can we say B equals to C? This is given to you. Only two cases are possible. It will become B bar, it will become C bar. This will become B, this will become C. So this statement is also true. Right? A plus B equals to A plus C and A is 0, then B equals to C. Yes, because A is 0. Clearly given. Very simple. What is the quick method in which you don't need to use your copy pen? Right? X 0, then result is X. And then now 0 to 0, 1 to 1. If X is 0, result 0. If X is 1, then result is 1. The result will be same as X, right? over here now see, A B bar C, A B XOR C. So near case 1, there will be two cases, A equals to 0, A equals to 1. Right? So in this, both of them will be same, and over here if A equals to 1, then again both of them are same, right? So this method is very supreme method. So now let me tell you, A XOR B equals to A bar XOR B. This is same as A XOR B bar, but this is not same as A XOR B whole bar. But this is same as A XOR B. Right? So these are same. Think about this logically. Why this whole is not same and why this is same to XOR. Let's prove this. A equals to 0 equals to 1. What will be the LHS? B. What will be the RHS? Okay, so 1 XOR B bar, that is B. Wait a minute. Actually, this is correct. A XOR B equals to A bar XOR B bar. Right, 0 XOR B is B. Now 1 XOR B bar, that is B. For LHS for A equals to 1, this will become B bar. LHS will become B bar. And now if you get A XOR B bar, A XOR B, so A bar XOR B bar XOR, and this A bar XOR B bar. How to remember these things? You can prove them, but how to remember them? So remember, this is your XOR. If you change both of them, Then listen to this logic. Right? So here they are different, here they are different. Right? If A is not equal to B, right? Then here also A is not equal to B. And if A equals to B, then here also A equals to B. So nothing is changing. Now notice here. If they are different here, then what they'll become? Then these two will become same. If they are same, then these two will become different. Right? Something opposite is happening. Now think logically. You don't need to apply the by case method here, just think logically. So this is the idea. A XOR B. If you change both of them, it is fine. Now A XOR B. If you change both of them, that is fine. Now see A bar XOR B. That is same as A XOR B bar. A XOR A plus B bar. Over here, A bar dot XOR A XOR B bar. So XOR, do you understand? Either you apply by case or you use logical thinking. So if they are different, they'll be different. If they are same, they'll be same. This is a question which has come in GATE exam. So you should understand this. A XOR B, A XOR B, this will be full complement. Right? Now So now you can see. Now from where this is coming? AX nor A is or whole bar A is or B A bar B plus A B bar. So this is the same thing which is written over here, right? Let's see how to play with logic gates now. You know De Morgan's law. Till xn like this. Now this one. Like this. Now let us solve a question. So tell me what should be the answer. Option A, B, C, D. First, before this, let's tell you one more thing. When I write like this is the symbol for AND gate, right? There is a bubble. A is coming, B is coming. Then what will be the F? This bubble simply means not. Not or inverter, right? This will be A bar, B bar. You can think like this. This is the AND gate. There is an inverter. Alright, think like this. Both of the diagrams are same. 1 and 2. You'll get A bar here and you'll get B bar here. This bubble means not. So you can notice over here this is an AND operation, right? This should be correct. What else should be correct? NAND is nothing but AND followed by NOT, right? NOT of AND. So this is also correct. And then you are doing NOT. Now you can notice this NAND. You can write XY bar X bar plus Y bar. So this is also correct. The same diagram can be made like this. So this statement is also correct. Now let's solve another question. Okay, so nor means not of or. So doing nor, then you are doing not. So first you do or, then you do not. Right? So this is also correct, and this is also correct. Now this you can find x by x bar y bar, and then you can add them. The same diagram you can write like this. So this is also correct, this is also correct. Okay, very simple. These concepts are very simple. Right? So digital logic is quite simple. Right? When we move to sequential circuits, this sequential circuit will make so easy. Many students fear sequential circuit, counter, register, and Mealy machine. Many things. Flip flop. Okay, so are they same? Right? So over here we can write it as this. So this is again same. Now question. Number of So tell number of different Boolean functions on one Boolean variable. Right? So tell, are they same or are they different? They are not different, they are same. This is also same as right, all of these are same to this one. So all of these expressions are same, they're not different. Similarly, a bar or a bar and a bar 0, a takes nor 1, a or 0. This expression is same as this expression. This expression is same as this expression. This expression is same as this expression, and all of these are same. These are also same. So how many different Boolean functions you can create on one Boolean variable? So if you have one Boolean variable, then how many rows will be in truth table? There will be 2 rows, either 0 or 1. Now how many functions you can create? F1, F2, F3, F4. For every row, how many choices you have? How many choices you have? 2 choices. 0, 0, 0, 1, 1, 0, 1, 1. So total 4 functions you can create. right? So your answer will be 4 for one Boolean variable. What is F1? 0. F2 is, that is A. F3 is A bar, and 4 is 1, right? So here we are creating on one variable. So on one Boolean variable you can create only 4 functions. So whatever expression you create, it will be one of these only. For example, if you create this, which is 1, which is again F3. So in a Boolean function, the domain is codomain is again fixed, 0, 1. So this function is possible, this function is possible. So fix it. So only 2 functions you can create, and these are only 2 functions, right? So this will be the constant function. Next we have so every variable has 2 choices. So there will be 2 power n row. So if you have n variable, then you have 2 to the power n rows. For every row you have two choices. So on n Boolean variables, so number of Boolean functions will be 2 power n. Okay, so this is just a small thing. Now one small thing, switches, Boolean expressions and logic gate circuit implementation, right? For example, so this is a physical circuit over here. You can find this circuit in your house. This is your switch. This is button. Now, have you seen switch? What is a switch? In our house, in our home, switch is like a button, like a fan button. Somewhat like this, right? On off, on off. So now you can notice this is a physical circuit and you can find this in your house. Power supply, the light, and here you are studying. So can anyone tell what expression can we take for this circuit? What will be the Boolean expression? This is the actual circuit. Now it's logical behavior. So when the light will glow, when? If either this happens or this happens, right? One of them should happen. So the light will glow. So with this, we are assigning this variable x1, this is x2, this is the logical variable. Now this type of circuit you can create from the market. This is the logic gate implementation. This is also circuit, physical circuit, and this is your logical behavior. Let's solve another question. So this type of light you can find in your house again. So you can switch on the fan with the two different buttons in the same room. So what is this? Here is the staircase. Switch here. And there is a bulb here. LED. Then what we do, if both switches are off or on, then the light is off. If one of this is off and another is on, then the light will be off. So this behavior is XOR, exclusive OR behavior. On. The light is on. Okay, light is on. The light will be on. So you can purchase an exclusive OR gate from the market. Switch 1, switch 2, and then what you can do, you can connect it to the bulb. So this is S1, this is S2. This is the bulb. This is the exclusive OR gate. So this is basically the functionality of your right. So this is the idea. Now let's move on to the next problem. Okay, so to design a circuit which realizes the following truth table. So it will be like this. In the next lecture, you will understand how to write from the truth table this expression, right? Okay, so like this it will be made. So that's all for this lecture. Meet in the next lecture.